Hi guys, Buildzoid here, and today we're going to be doing a video that, I have no idea if this is going to work, but it's kind of interesting. So, as you can clearly tell by all of the tape on all of these, I've gone through all of these sticks, and I've tested them for DDR4 5000. Yes, every single one of these sticks. So we obviously have, and these are all single rank, 8 gig DIMMs, so Micron Rev E. All the black ones are the ones I got sent as review samples by Crucial, so thank you to Crucial. The silver ones are the 3000 CL15 sticks that I bought sometime last year, so big thank you to the patrons for funding all of those. And yeah, basically, I don't have a lot of experience overclocking Micron Rev E, and now I have a ton of it, and so I basically got the idea. Hey, let's try bin it for some settings, and initially I was trying 3800 CL14, and basically all of the sticks were doing it at the same voltage, so that was okay, it's not a good binning criteria. And then I got the idea. Hey, let's test them for DDR4 5000. And that didn't really go much and initially that actually looked like a relatively promising binning method because a lot of the sticks wouldn't do DDR4 5000 until a fan of the channel came along because I was live streaming this, came along into the chat and was like, yo, Buildzoid, did you try lower VTT DDR? And I'm like, no. And he's like, well, try that. And so at really low VTT DDR, not on BDI, you sometimes need to bump down the VTT DDR 50, 100 millivolts or something. But these sticks, some of them are off by, this stick right here should be over should be over 0.8 volts for VTT DDR, but it's 0.7. And I don't think that's the worst one. There's one stick where it's 0.6 to 1. Oh yeah, this one's 0.71 for 1.7. Right, so that's a really low one. This is a 1.7 to 0.7 as well, but this one doesn't actually do 5000. This is the only stick in this entire set that doesn't do 5000. So yeah, he suggested that I start messing with the VTT DDR and running it really low, and so I did, and suddenly all of the sticks started doing 5000. So that wasn't really a great binning criteria, as I quickly learned. Yeah, the crazy thing is we have sticks here that are literally these silver ones. They're all 3000 CL15. What's this stick? This is a 3000 CL15. This is a 3600 CL16. I think this is also a 3600. Yeah, this is a 3600 CL16. This right here is a 3200 CL16. This is a 4000 CL18. That's a 4000 CL18. I think that's another 30. So basically, what's crazy here is that we have sticks, and admittedly, I wasn't testing them for full stability. It was just can I get into Windows? Can I save a screenshot? Maybe even run Geekbench 3. And the crazy thing is, yes, some of these sticks can actually do, this stick right here, I think actually runs Geekbench, which is absolutely insane. This is a 3000 CL15 stick that can do 5100, DDR4 5100 and at CL18. And the timings were all the same on them because I didn't really want to mess around with that. So one thing I want to do want to test for in the future is TRCD behavior, because that should actually be there's some pretty major TRCD differences between these sticks. This is a 4000 TRCD 19, and then the worst sticks are 3200 TRCD 18. So the TRCD to frequency ratio can be kind of all over the place from the XMP spec, so I'm wondering if that might not be a better binning criteria than what I've been trying to do so far. But yeah, the crazy thing is if you have VTT DDR control, proper VTT DDR control, you can actually push basically this is, what is it, 12 sticks, right? Every single one of them except this one does 5000. Admittedly, some of them need a lot of them need very specific voltage settings, but they do 5000. And I didn't test for full stability, but that's still insane. Booting 5000 at all is ridiculous. For a while, that was literally the DDR4 frequency world. If you could do 5000, that was basically a DDR4 frequency world record. And now you can buy, these sticks right here. These were, I got one of the, I think I got this stick, or, well, some of these sticks right here. I got some of them for, 35, 40 quid a stick, right? So these are really, really cheap. The like basically all of the Crucial, like the 3000 CL15s and the 3200 CL16s from Crucial, those go for like $70 to $80. Like, we have a lot of really cheap RAM here. Also, if somebody's confused about me saying quid for these and dollars for the rest, well, I actually bought the ones that I remember the quid, like the pound price, because yeah, I am in the UK. Anyway, um, yeah, so we're just going to go through these, and I'm actually going to show them like booting the settings and how drastic the difference is between having the voltage settings correct and not having it correct, because it's crazy. It makes such a massive difference. Um, and anyway, so for the motherboard that I'm going to be using, and the motherboard that I did all of this testing on, was the X570i Strix Buildzoid Edition. Now, I call it the Buildzoid Edition because I've done some extensive modifications to the memory, uh, everything on that board. So if you buy the retail motherboard, you can't actually set VTT DDR below half VDIM, which yeah, that is not a good thing, as I think there's like, I think it's just this stick, and yeah, like these three sticks right here are the only three sticks that work at 5000 with VTT DDR of half VDIM. So for 1.65 volts, yeah, 0.83 is correct. 1.6, 0.8 is correct. 1.55, 0.78 is correct. And then everything else, it's like this is a 5100. Like, this is one of the few sticks that does 5100. Admittedly, I didn't actually consistently test for 5100. It was just like I randomly decided to try it with this stick, and 1.65 to 0.7. Yeah, like this should be at like 0.83 by spec, but like the DDR4 spec is VTT DDR is half your VDIM. So for 1.65, it should be at 0.83, but nope, it doesn't work at 0.83. So yeah, pretty crazy, like crazy differences between the sticks. And the motherboard has modifications like extra memory voltage range, which also included a full swap of memory capacitors, because the reason why the board normally only has a memory voltage range uh, up to 1.8 volts, which we don't need. Like, this is Rev E. I wanted the over 1.8 volts range because of Samsung V-Die, but yeah, with the Samsung V-Die, like, the thing is, normally this board has a bunch of 2-volt capacitors for the output filtering for VDIM, so you can't shove 2 volts into 2-volt capacitors, because if you have ripple and that, yeah, that's not good for them. Like, the voltage rating of a capacitor is like the maximum voltage it can handle. So if you want to, filter something like a 2.5 volt, like a 2-volt rail, you should be using like 2.5-volt capacitors at the very least. So yeah, I had to swap all the capacitors on the board. Now it goes over 2 volts for memory voltage. And then I also have a trimmer, and like I have a trimmer for VTT DDR control, because normally this motherboard only allows you to increase VTT DDR control, which is completely stupid in my opinion, because again, I'm not the world's best memory overclocker, but in my experience, raising VTT DDR never actually does anything. Like, I've never seen it help any memory overclock better, but that might just be because I've not tested all of the different memory ICs to ever be created, so maybe there's some IC that I'm not aware of where that does work, but generally speaking, you're probably going to be pushing VTT DDR down, not up. So it's really weird that the board, has this it's a half implemented VTT DDR control where it also goes in the less useful direction. So yeah, so I have modifications to fix all of that, but that does mean that, yeah, you can't do this with a retail X570i Strix. However, I do plan to, so today we're just going to go through all of these, and I'm going to show that they do 5000. But in the future, I'm kind of toying with the idea of taking some of these sticks and also testing them on some other motherboards, where we do have proper VTT DDR control, because I think it's pretty silly. Because more like I want it to be a bit more relatable than it's like, look, my super modified motherboard can push these sticks to crazy settings, when it's if you wanted to copy some of these settings, because these are 3000 CL15 these are 3000 CL15 sticks, right? Like, these aren't special, they aren't expensive, and if you want to make if you're gonna get into HW, like if you're gonna go on get into hardware bot benching competitively, there's a lot of points in just being able to post a high DDR4 frequency. screenshot, and I'm just gonna check how many it is right now. But I think it's like 20-ish points for DDR4 5000. And hardware bot doesn't want to load for me because I'm trying to use Firefox. Whatever. So yeah, let's just get the board into the shot. Go. Also the multimeter, because yeah, the board does not see the volt mods in action, so we need the multimeter to actually monitor the voltage. This is the VTT DDR readout right here. So that's just soldered up behind the board. And then I also have a VDIM measurement line, but we don't need that because all we really care about is VTT DDR. Like, it's really easy to tell what voltage you're at just from looking at the VTT DDR, and also the fact that basically my memory voltage mod is just a plus 20% setting. That admittedly no longer is, like, once you get up to the high voltages, it's not 20% anymore, but at low voltages, it's pretty consistently 20%. So, yeah, I don't really need I don't need super precise control over VDIM. I do need really precise control over VTT DDR. Anyway, I'm just gonna put the mic on the stand, and let's get into it. So which stick should I start with? Let's start with a oh, and the PSU's off. There we go. So now this is turned on. The multimeter on. So just gonna ground off of the standoff there. This is not the most accurate way of taking voltage measurements, but VTT DDR isn't a high current rail. It's not really going to skew the measurement too much. So, yeah, I'm not really worried about that. I'm just going to that hooked up. And I'm actually not sure if the mod's active right now. Also, the board is probably on settings for one of these sticks already. Let's start with the 3000 CL15 5100 capable stick, because that'll actually run Geekbench. And I did test them one stick at a time. Also, you'll notice I have Silver Sharpie on this DIMM slot, and that's because this DIMM slot is the one that I can't remember if I tested it, but this is the DIMM slot I've been using for all of the high frequency memory stuff. I'm pretty sure the other DIMM slot is actually just worse at that. So, yeah. There we go. So that's the stick installed, and let me just pull up the capture card. Oops, nope, that's not what I wanted to do. So I do want you to be able to see like the post LEDs. So let's push that up a bit more. The multimeter, there we go. Yeah. And right, power button. Okay, so right now it's at 0.85 volts. So the thing is, it'll still boot. And I think it's, I don't remember which DIMM this is tested for right now, like which DIMM this is configured for right now. But yeah, so that just booted 5000. But the problem is, and what voltage are we set to? We're set to 1.7. Yeah, okay, so that is probably one of the worst DIMMs that I tested, but we're going to set that to 1.65. And we're going to bump this up to 5100, which is still going to post, but the problem is it's not going to make it into Windows until we adjust the VTT DDR. Now, also, I didn't check what is the optimal VTT DDR setting for every single stick. I just tested which VTT DDR is good enough, as in the first VTT DDR setting that I tested, if it worked, that's just the one that I wrote down, because there is a lot of sticks, and it takes a while to test them all. And this better not work. It's not supposed to work. Oh, come on. Okay, well, I didn't check what exact requirements every single stick had, so I guess I under-tested this one. But there's definitely some sticks where the VTT DDR is absolutely critical. So anyway, let's just pull up CPU-Z. We're not going to run IDA because we are in single channel and it's just going to score horribly. But yeah, that's 20, that's 5.1 gig on a 3000 CL15 stick, which is absolutely ridiculous. And now I wonder if it'll actually run Geekbench. So this stick seems to have really good VTT tolerance. Because some of the other sticks shouldn't be, like, they'll all post, but some of them shouldn't make it into Windows. Without having the VTT DDR dialed in. The issue is that I literally went through, like, once I realized what the issue was, I literally just kept the VTT DDR low from a certain point in testing. Though, admittedly, I also have, like, I think some of the Max sticks, actually, like, the Max sticks, I don't think work with low VTT DDR at all. So if I set it too low, those actually have issues. But again, this is mostly like this isn't about proving like full stability. This is more like, look, like it's just insane that you can have sticks like this do stuff like this. Also, the voltage is fluctuating because as the memory goes in and out of load, the VDIM fluctuates, and so the VTTDR goes up and down a little bit as well. But the multimeter does like measure down to, so like the 4 is millivolts, and that's tenths of millivolts, so we don't actually care. So yeah, like 5100 runs Geekbench. So we're gonna shut down, swap stick. Actually, we're not gonna swap sticks because if I swap in another stick, it's not gonna post. So I'm gonna drop it down to 5,000. And we're going to try one of the sticks that I'm actually pretty sure requires the low VTT DDR instead of a stick that seemingly... Like, this stick seems really, really good. So, yeah, but I already knew that because it's the only stick that I could get, like, one of the 2 sticks that I got to 5,000 at all. I mean, 5,100 at all. Okay, so it posts. And we're just going to shut down as soon as I get into the BIOS. And then we're going to switch in a different stick. So yeah, that's a 3000 CL15, and it does, freaking 5100 if you get the, well, actually, like that one isn't even voltage sensitive, so that's really annoying. So let's find one that is pretty voltage sensitive. This is a 3000 CL15 black. This is a 0.67. What is it? This is a 3000. This is also a 3000 CL15. And this one's actually lower voltage than the other one. So I assume I tested them in some form of order. And this one is more sensitive. So hopefully this one doesn't make it into Windows, because it's not supposed to. So this is 1.55 volts on this one right now, on the label. So actually, because we're at 1.65 volts for VDIM right now, which we know because the VTT DDR is going up to half VDIM. Like, it'll still post. It'll just not make it, like, it shouldn't make it into Windows. Please don't prove me wrong. I hate it. Like, this is one thing I hate about memory overclocking is like, oh, I'm going to demonstrate this thing, and then I try to do it, and it doesn't do it. Like, it works when it's not supposed to, or... Please crash. There we go. Ah, there we go. See, that's what's supposed to happen. So... Admittedly, this stick is labeled for 1.55 volts, so let's just drop the voltage to 1.55 volts, and it still won't work. And also, this is another 3000 CL15. So, like, yeah, I still find it so ridiculous that such cheap DDR4 is capable of such insanely high settings. Like, they're not fully stable, but... Like, being able to boot these kinds of settings at all is an achievement. Okay, so now it's very upset. Yeah, very upset. So I'm just going to flick the VTT DDR switch. And now you'll notice that our VTT DDR is going up significantly lower, and it's not upset anymore. It just trained instead of, well... It might have actually hit the safe mode right now. Actually, no, it didn't hit the safe mode because the VTT DDR is not half 1.2 volts. So right now we're at 5,000, 1.55 volts and 0.65, which I think should be close enough to the 0.67 on the label of the stick that this will work. Because basically there's a... like, again, I didn't test the full range of voltages that work. I just tested, hey, does this work? Yes, it does. Stick it on the label, put it on the stick, like, put some tape on the stick, write it down, move on. Because too many sticks. Yeah. Also, I do want to test this on some motherboards that don't need a modified VTT DDR rail. because it is like it is kind of, you know, just unrealistic. And the thing is, you can get perfectly good motherboards that have VTT DDR control. I really don't get why Asus decided that, you know, a relatively high-end X570 ITX board doesn't need. Actually, one of the most expensive X570 ITX boards doesn't need proper VTT DDR control. So I will probably be testing it on the ITX X570 Gigabyte, which I don't think I'm going to do like a full video. I'll just list off all the boards where I've checked the DIMMs to behave as they should. So this won't run Geekbench, but now we're in Windows, whereas previously we weren't. And I mean, I'm not going to flick the switch while it's... Actually, I've done that. I've flicked the switch while it's running in the past, and it doesn't really... Like, I've never run into issues with that, but that doesn't necessarily mean it's safe. But yeah, so 2500... and all you need to do is just get the VTT DDR right. I don't think this will run Geekbench, because again, I wasn't testing for full Geekbench stability. I think this will crash at Dijkstra, which is like the heaviest memory workload that Geekbench throws at your CPU. Okay, and here comes Dijkstra, and... Oh, it passed. It's not supposed to pass, but... Okay. Maybe maybe the VTT DDR being now even lower than than the voltage on the label is actually helping. Like, again, it's just like this is more like this isn't really supposed to be a guide for Rev E overclocking. It's more like, look how cool it is. You can do 5,000 on incredibly cheap RAM. And you know what? I'm pretty sure if I spent enough time fiddling with these, I could probably get them stable at these kinds of crazy high frequency settings. But again, it's just like, well, I don't know. The thing is, if you're running DDR4 5000, there's really only like one like for Rev E, at least in my experience, like Rev E on Intel, I've been having huge issues with running high frequencies, and it's been really like not going well. But running Rev E at high frequencies on AMD is really counterproductive, because you're better off running with one-to-one, you know, FCLK, UCLK, whereas if you're at DDR4 5000, your UCLK and FCLK are completely out of sync, and you get that latency penalty. So the performance, like, it's not as bad as it could be, but it's definitely not, you know, great. Like, it's not an efficient way of trying to run the memory. Anyway, so that's another 3000 CL15 stick that does 5 gig, which is absolute, like, it's insane. Like, it's absolutely insane. So let's switch in another stick. Let's try something a little bit... Let's try a max stick, right? Because one of the... Like, let's try the 5100 max stick, which is this one. Because that one needs a high VTT DDR, or at least it should need high VTT DDR. So I don't know if it'll even train on this. There we go. Power on. And, oh, it trains. But will it make it into Windows? I mean, I'll bump it up to 5100. Label says 5100 at 1.65, so we're right now at 1.55, so maybe the thing is, the sensitivity of memory sticks to basically everything scales with the actual memory settings themselves. So if you're running the sticks at, like, a lower frequency or looser timings, then they're less temperature sensitive, and they're less voltage sensitive, and they're less everything sensitive, really. So that didn't work. And it didn't work again, so I'm just going to flick the switch. And now instead of going up to 0.6 volts, we're going to see it go all the way up to like 0.8, and it still doesn't work. Okay, well, that's really annoying. It's supposed to work now. Oh, now it works. Oh, no, it reset itself. So the voltage is now 0.6, which is 1.2 volts, so it just entered safe mode. I wonder if maybe I've like got grease on the gold fingers or something. Because the thing is, when you're pushing really high memory frequency, like, a bit of dust in the memory slots can actually screw you over. So if I grab the sticks wrong, then we might actually, like, that might actually be upsetting them at this point. I'm just going to go for it. No, they're really not happy with that. That is very weird. This is supposed to work. I kind of want to give up on this one, though. Okay, we'll just bump up the voltage. Because the thing is, like, a lot of the other sticks have, like, very strict... Well, a lot of the other sticks, if you just keep raising the voltage, they actually get worse. The max sticks generally didn't do that. Please work. Oh, come on! Like, this is the 5100 stick that you saw on the... Or actually, I didn't run it 5100 on the Steel Legend, but... I did run it at 5000. Well, it did 5000, so that's actually not that surprising, is it? I wonder if I got them wrong. Like, I wonder if I got the labels on the wrong sticks, but... Yeah, no, that is the right stick. Okay, well, that's really disappointing. I'm not actually gonna, like, clean it here, but... It did 5000 at the very least. So I'll drop it back down to 5000 and we'll call that a success. And actually, while we're already in the BIOS, there, man, English. I don't know why that was so difficult. I may as well show you the settings. So 18, 26, 26, 52, 100 TRC, TRFC completely maxed out, which is like you just max out TRFC if you're going for max frequency attempts. That's just what you do. Proc ODT 32 ohms. It has to be 32 ohms. At any other settings, it does not work well. And then for the drive strengths, it's just 20 ohms for all of them. And that's actually the same setting. Like, I use these settings for all of the sticks. Now, again, I've not tested for full daily stability. I've just been testing for, like, can I do 5000 on this random stick of 3200 CL16? And with these settings, indeed, I can. Okay, so now it trains, and I don't really, like, if I take every single one of these into Windows, this is going to take a while. But, you know what, we'll take it into Windows. Because there is a lot of sticks. And I just realized I put one of the ones I just tested already back onto the pile. So we're actually not going to go through every single one of them, because I forgot that I need to keep track of which ones I've already run. But if we Windows zoom on this, 2500. Which, yeah, like... But that's a 4000 CL18 stick, so that's not really that impressive, is it? That's like a top stick from Crucial right there. So they literally, well, they do have a 4400 bin that's going to be coming out eventually, but yeah, for a while 4000 CL18 was literally the best stuff you could get from them. So let's try a 3200 CL16. So this is a 3200 CL16. This one actually this one actually has, like, reasonable voltage tolerance at 0.78. So I'll also grab the other 3200 CL16 that doesn't have reasonable voltage tolerance so that we can do a direct comparison between the two. This is a 3600. This is a 3600. This is a 3200. Okay, so this is a 3200 0.67, and this is a 3200 0.78. So this one does half VDIM, and the other one apparently doesn't. But again, with how I've been testing them, I wouldn't trust my own labels at this point very much. So, yeah, good job me. Well, let's fire this one up. And this one should have no problems. So, like, I'll just let it go all the way into Windows, because it's still set to 5G. The settings haven't changed. So yeah, that one goes straight into Windows just like that. If we open up CPU-Z. It's a real shame that we don't currently have a platform where it makes sense to run settings like this. And that's 2500, so yeah, let's power this one down and switch to the other one, which hopefully will immediately not post or like blue screen as soon as we get to the loading screen. Because yeah, like that one has a label that says it should do that, but we'll see, because as we've seen, there's already been one stick where it's like, oh, the label says that it'll do this, and then it's like, oh, but it also does this other setting, a combination of settings. Anyway, let's get this one in there. So this is also a 3200 CL16. It trains, which I'd expect. Like, all of them will train basically all the time, but not all of them will be stable. Now, that's just not fair. Okay, well, we'll have to, like, okay, this is a, what is this? This is a 3000.67. Okay, now, 3616. Let's try one of those, because I've not tried one of those yet. This is the issue of me, like, not actually, like, proving the settings for the various DIMMs. It was literally just like the first set of, like, because basically I'd test one DIMM, and if one DIMM required low VTT DDR, then the next DIMM would also get low VTT DDR just because it was already set to low VTT DDR. Anyway, you can clearly see that's 2500 again. Let's power this one down and stick in another stick. And what I find really crazy is, like, at this point you might be like, oh, Crucial must have sent you a bunch of like uber bin memory sticks, which is why they all do 5000. And it's like, well, no, because there's also all the silver sticks that I literally bought from eBuyer for, you know, like 30, 40 quid each. And those also do 5,000. So, yeah, Rev E is just kind of ridiculous like that, where with the right combination of like drive strengths, termination, and voltage settings, you can do 5,000 on basically any kit. I do have it the right way around. What the hell? Why is it not going in? Go. So that's a 3600 CL16, I think, right now. And this one should train, but it shouldn't make it into Windows. Oh, it's better. It won't even train. So I'm just going to flick the switch. Now you can see it's going up to 0.65, and bam, it trains. Amazing. Right? Like, and this is the thing that I find so annoying about memory overclocking, is just like, if you have one setting wrong, nothing works. And then if you get that one setting just right, suddenly it's like there was never an issue to begin with. So, yeah, and so that's 5,000 right there. So this one actually needs the reduced VTT DDR. Though admittedly now we're at 0.65 instead of the 0.67, but that's on the label, but, you know, there's I assume there's a range of voltages that work, and if you dial it in perfectly, then you can probably maybe eke out another like 50 megahertz of, you know, real clock speed. Because DDR, like I say 5,000, but DDR, well, DDR4 5000, the effective speed is 5,000, but the actual frequency is 2500. Anyway, which is why CPU-Z shows 2500 when we're at 5 gig. Anyway, so that stick does do that. So I'll just switch the termination mod off and just demonstrate that it won't train again. So actually, first, that it trains. Because like, this is the thing, like, if you've done a lot of memory overclocking, right, you're probably experienced with how unreliable memory overclocking kind of tends to be, especially when you're pushing really aggressive settings like 5,000. We've got 5,000 in the BIOS. So now I'm going to turn off the modification. right? Voltage was going up to 0.65. Now it's going to go up to 0.7 something, and it's not going to post anymore. Wait, are you... What? Is this just like a training requirement or something? But it wasn't working. What? I wonder if it's just some kind of weird, like, memory training thing with the memory controller. Where it needs the termination really low initially. And then after you've done that, it just starts working. I hate RAM. I really, really hate RAM overclocking. Wait, I'm gonna turn off the power supply, turn the power supply back on, and then try to power it on again, because that should clear, like, that you can that essentially does what a retry button would do, which basically resets the memory training parameters. So that's power supply off. Power supply back on again. I will say the RGB is actually useful for indicating if the motherboard is on or off. And now it stops training again. So yeah, it does look like it is some kind of weird training behavior. Come on. Power cycle, you stupid motherboard. Okay, so now it's stuck. So yeah, it looks like there's some weird training parameters that are tied to the VTT DDR on the memory controller. And if you, like, once those are dialed in, oh wait, no, now it's working. I hate RAM. I really hate RAM overclocking. Like, why won't you do the same thing twice? Right? It's like, I'm doing the same thing over and over and over again. And the results do change. So, yeah, if you want to go insane, get into memory overclocking. That's a one-way trip to the insane asylum. So this stick says 1.55 volts, 0.67. This is another one of those silver 3000 CL15 sticks. Please don't work. Alright, do I have this one backwards? Oh yeah, I do have it backwards. So this one should need the mod, but again, now I'm not sure because it's like... Okay, it's stuck. Power cycles. Power cycles again. Please. Yeah, okay, I'll turn the mod on. So now we're at 0.65, and it's still power cycles. Okay, so that is a problem. Man. Here I was hoping I'd have a nice, clean video about memory overclocking. Instead, I get this mess. So now it's in safe mode, which is why the voltage is at 0.5 volts. Like, we might be a little bit low on the termination right now, so I'm gonna bump up the memory voltage a little bit, and we're gonna reset. Because it did say 0.67, it didn't say 0.65. Right, so again, it might be like 0.65 might be a little bit too low, and 0.67 is just right, or maybe, you know, 0.66 seems to be just right as well, so... I hate RAM overclocking so much. It's like, if it was at least consistent. But it isn't. It's just like random stuff happens, you change numbers, and sometimes they work, and sometimes they don't, and sometimes after you power cycle the system 3 times, it stops working again. Which is just great. Yeah, so now we're doing 5,000 again. But still, it's like, this is, again, a 3000 CL15 stick, which is ridiculous that... Like, the fact that this works at all, regardless of how unreliable it is just like, that is amazing, as far as I'm concerned. Like, there are, like, this is hard to do in general. No? Oh, come on. Whatever, we'll just power down. So there's only one stick left. Let's try another 3000 CL15, but this time a black one instead of a silver one. This is one of the review samples from Crucial. Whereas all the silver ones, again, I bought those, and the silver ones do 5000 as well, which is, except for one of them. Though at this point, I'm kind of scared to try that one because it might start working. It says 4K 4900 on the label, but now it's like, what if I stick that one in and it boots? Like, I don't want to deal with that. And then there's also one that needs like 1.7 VDIM, which is insane. Anyway, so yeah, that's another 5000 right there. I wonder if this one will actually behave according to what the label says. Like, this one has a label that says it needs 0.67 VTT DDR. So if I shut this down, disable the VTT DDR mod, it should stop posting again. But as we've seen with a couple Systics already, that doesn't actually seem to work the way it's supposed to. So yeah, that's 2500 again. So let's just power down. I'm going to flick the switch for the mod. Oh wait, no, mod's on. So now the mod is off. Now we're going up to 0.7 and it's training again. Freaking RAM. Wait, please don't make it into Windows. Do me a favor. Blue screen? No blue screen? Oh, come on. Oh, wait. Oh, wait. Sometimes... Please lock up. Please lock up. Please lock up. Come on. Okay, I think Windows exploded. Which, like, if you're doing memory overclocking, because memory overclocking just causes... Like, we're now going to be perma-stuck on the loading screen, I think, until, you know, until an error big enough in the memory happens that... Oh, no, it just worked. Okay. Still... Oh, wait. Oh, no. Wait. It is being kind of spotty. Like, that's the thing. Like, if your memory settings are really unstable, sometimes they'll just exhibit very strange behaviors. Once you actually get into the system, because the thing is, you would think if the memory is unstable, it'll just immediately cause an error that just takes down the whole thing. But a lot of the time, it causes an error where it just, like, you just start getting really glitchy behavior and it doesn't just crash. So that's the other annoying thing. And yeah, like, I've had memory overclocks where I'd get into Windows and then, like, the start menu wouldn't load, or none of the icons would load, and you just have a blank desktop. But like, replicating those kinds of symptoms is borderline impossible because they happen at random. And then, of course, we have... Oh, there we go. So, yeah, now it is unstable, but, like, previously it might have been unstable as well, and there's no way for me to really prove that. Like, it might have been moderately more stable, and it's like, you'd have to run memtest, and even that, like, sometimes you get the error really early and sometimes really late. So, yeah. Anyway, I just kind of wanted to show, like, you know, that with the... Like, again, with the right... like, some of these sticks do actually do what the labels on them say, and some of them seem to just be Schrodinger's memory sticks, where it's like the voltage requirements change on, like, based on the position of the sun and moon. Yeah, so there. Micron Rev E, if you're into very high memory frequencies. Like, again, the thing is, because the timings are so incredibly loose on all of these for these settings, the performance is not there. Like, they're not actually very fast. But it's still crazy that, you know, like, if you're into competitive overclocking, being able to post a 5 gigahertz memory score it's a good, you know, good bit of points you get. Though, admittedly, I've just taken all the fun out of it, because it's like, yeah, you just set your terminations like this, you set your drive strength like this, and then you just whack like 1.5 to 1.5 to like 1.7 volts into your DIMMs and potentially adjust VTT DDR, and basically all of them do 5000. So, like, the fun part, in my opinion, is figuring out how to make it work. Even if somebody gives you a tip like, oh, you should try lower VTT DDR, that still counts. But yeah, at this point, like, I've taken all the difficult stuff out of this, because the difficult part, in my opinion, is like the termination setting, like the drive strengths and all of that. Like, that took me a while to figure out. You do have to mess around with which DIMM slot you're using. Now, on an ATX board, you're always going to be using the DIMM slots, like you're going to use the last DIMM slot in your daisy chain. Even if you're on a T-topology board, some T-topologies use like a hybrid T-topology where it's partially daisy chain, and you still need to like on those you still need to use the last DIMM slot in the chain. So basically on ITX boards, each DIMM slot is the last slot in the chain because there's one slot per channel. But if you're on an ATX board with 4 DIMM slots on an M18, if you have a motherboard with 2 DIMM slots for each memory channel, you have to use the DIMM slot furthest away from the the DIMM slot for that channel furthest away from the CPU, because obviously the very last slot is actually for like one of the specific channels, right? So yeah, anyway, actually I'll just do another video covering that with a more budget board. I actually want to try 5000. Like, I have a B450, like a really cheap B450 board, like a $70-ish B450 board with 2 DIMM slots. So I'm probably going to be trying 5000 with some of these on that board, because it's a it's a 2 dimmer. Like, yeah, it's $70 and it's a 4-layer PCB, but it's a 2 dimmer, so it should still be very capable in the department of memory overclocking, just because you don't have a whole extra DIMM slot screwing up your signal integrity. So, yeah, anyway, hopefully that was somewhat interesting, even though I've just discovered that the labels aren't all completely accurate. Also, that memory, well, I've not discovered that RAM is a horrible, unreliable mess. That's just what RAM is. Yeah, hopefully you found that somewhat interesting. And, you know, this might actually help you stabilize some Rev E overclocks, because obviously, like, yeah, apparently you do have to tune the VTT DDR with some of these sticks quite a bit. With some of them, not so much. But anyway, that is it for the video. So, you know, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below if you'd like to support what I do here with the channel. I have a Patreon. There's a link to that down in the description below, which, speaking of the Patreon, thank you for the multimeter and the motherboard and the CPU and the power supply and the silver sticks. Thank you to Crucial for the black ones. And what else was there? So yeah, there's the Patreon. Other than that, there's also the AHOC Teespring store, where you can pick up shirts, stickers, posters. There's a new shirt design there, which is RAM overclocking themed. That's also part of the reason why I'm now capable of doing 5000 you know, megahertz on basically every kit of Rev E I get my hands on at this point, because I've done that ritual. Very makes you a better memory overclocker. Anyway, so yeah, you can check out those links if you'd like to support the channel. And yeah, that's it for the video, right? I'm not forgetting anything. So thanks for watching, and goodbye. Now, oh, wrong mouse. Goodbye again, I guess.